Alright guys, now that we've seen some examples on solving literal equations, we are now going to look at literal equations that we may be more familiar with or may recognize, and those are also known as formulas. So a formula is a literal equation that shows how one variable is related to one or more other variables. Again, a formula is an equation that shows how one variable is related to other variables. All right, so some formulas you may be familiar with are area equals length times width, or volume equals length times width times height. So those are some common formulas that you may have heard or worked with already before. So looking at our third example, we're going to be rewriting the formula for surface area. We're going to be working with surface area of a rectangular prism. Nothing too fancy. So here's our rectangular prism. The surface area for this would be, let's look at the top face, say of a box, and the bottom side of a box. That's going to be the length times width, but there's two of them. So 2 times the length times width. Now let's look at the size of the box. That's going to be let's look at the front side of the box and the back side. That's going to be the length times the height. And there's two sides, so length times height. Now we're going to look at the sides of the box, and that's going to be width times height, and there's two of those as well. So that's going to give us our complete surface area formula. We are going to rewrite this formula and solve for L, or solve for the length. So again, you can circle the variable that you're trying to solve for. I will go ahead and rewrite my formula and highlight or use a different color for the variable that I want to solve for. All right. Remember, our goal is to isolate L. Our goal is to isolate L. Our first step is to get rid of any term that doesn't even have L on it to the other side. So since this term right here doesn't even have what we're looking for right now, we're just going to go ahead and move it to the other side. To undo this addition, we're going to go ahead and subtract this term, so minus 2WH from both sides. Let's go ahead and simplify. That's going to leave us with S minus 2WH equals 2 times LW plus 2 LH. All right, notice how this is very similar to our example number 2. Since both of our terms share an L, it's almost as if we can take back those L's from both terms. So we're gonna go ahead and take out or take away these L's from both terms. And what that's gonna leave us with is S minus 2WH. And since we took away this L, we can leave it like that. And we're gonna multiply that by the terms that we shared the L with, which is gonna be 2W plus 2H. Go ahead and pause the video right here just so you can make sense of how I took out this L from both terms and how I got back to here. So it's kind of like distributive property, but backwards. Perfect. Now that we have pulled out this L, remember it is very similar to our example number 2. In our example number 2, we had this situation going on where we had y equals x times 3 plus 5z. So that's very similar here where we have s minus 2wh equals L times the quantity 2w plus 2h. So remember again that when we see a variable right next to a pair of grouping symbols like parentheses, that means multiplication is happening. So to isolate our variable L, we want to undo that multiplication by dividing both sides by the term it's being multiplied by. And in this case, that means we're dividing by 2w plus 2h on both sides. Again, we are dividing both sides by 2w plus 2h because that is what L is being multiplied by. It is being multiplied by the entire quantity 2w plus 2h. So to isolate our variable, we want to undo the operation, which means we're going to use division. So that means these are going to cancel. So we are left with s minus 2wh divided by 2w plus 2h equals L. Or if we're not comfortable with the L on the right side, we can go ahead and rewrite it, giving us L equals s minus 2wh, all divided by 2w plus 2h as our final answer. Again, we know that we're done because we have solved for L, meaning we have L all alone on one side and all of our other terms and all of our other variables on the other side. Go ahead and pause the video here and let me know the definition of a formula.